In problem 22.30, we've got two non-conducting plastic sheets. You can see right there. Okay. And you can see that those are, and they have surface on each end. They have surface on each side. Okay. Now, those aren't too bad either. They have a surface on each side, and basically they're four sheets is what it's going to be like. They're going to have one sheet on the left side of the first piece, the left side of, or the right side of the first piece, the left side of the second piece, and the right side of the second piece. And they each have a slightly different surface charge density on them. So the fields are going to go kind of like this. They're going to go in toward this one. They're going to go out of this one. They're going to come out of that one. And they're going to come out of that one. We need to keep that in mind because that's going to give us some ideas about when to add and subtract depending on which one we're looking at. First, let's find out what the values of the electric field for each side is. We're going to use the same equation for all of them. We're going to use E electric field. Same thing for a flat sheet. Surface charge density, maybe, over 2 epsilon naught. Okay. Something for each surface over here. Okay. They're all going to look almost the same. So the first one is going to be, it's just going to be the, and I'm just going to do the values themselves. So it's going to be 6, because it's nanocoulombs on there, times 10 to the negative 6, over 2 epsilon naught, so 2 times 8.85, times 10 to the negative 12, and we're going to get 3.39 times 10 to the negative, 10 to the negative positive fifth. It's newtons per coulomb. Okay. We're going to do the same with E2, but this one's going to be, but instead this time we're going to have 5 times 10 to the negative sixth. Again, divided by 2 times epsilon naught. Let's pile that out. We're going to end up with 2.83 times 10 to the fifth newtons per coulomb. E3 we can figure out. Again, that one's just going to be, we're going to use the 2 microcoulombs. So it's going to be 2 times 10 to the negative 6 divided by 2 times epsilon naught, negative 12. So we're end up that time with a 1.13 times 10 to the fifth newtons per coulomb. And E to the fourth, I'm going to actually be lazy about it. It has twice the amount of surface charge density as E3, so it's going to have twice the electric field that comes from it. So we figured out each of the surface charge densities. Now we're going to look at the points and find out what the electric field is at each point. So I rewrote all of them up there after we've done our work. And I want to remind you again that our electric fields go like this. The surface on the left has an electric field that goes like that points inward because it's negative. The one on the right of the same slab is positive, so it's going to have a field that comes out like this. The third slab is going to have a field that goes like this because it's positive. Okay, I'm doing that just as a reminder. And the fourth one is going to have one that goes like in this direction. Okay. Those are just reminders, and we need those for when we're adding them together. So the first point we're looking at is point A, which is way over here. The diagram looks like a mess, but you can see it. Now you can see that from that direction, we have our field is going to be, means our first field, E1, is going to be positive. So it's going to be 3.39. I'm just going to add the coefficients for the first one. Write down A first. A, 3.39. Remember that one's going to be to the right. E2, okay, remember it's going to come out of this one. So it's going to be to the left. It's going to go the opposite direction. So it's going to be minus 2.83. Okay. The third one comes from this side over here. If I'm at that point, it's going to be to the left, minus 1.13. Okay. And if I'm over on the left side, if it comes from this surface, it's going to be the left also. Okay. So it's going to be minus 2.26. I subtract all those numbers, and I get negative 2.83 times 10 to the 5th newtons per coulomb. Again, the negative just tells me the direction that it's going to point to the left. Okay. Next point we're looking at is B, which is right here, right in between the two slabs. So for that one, for E sub B, this time again, our lines are going to be toward that plate on the far left. So it's going to be negative. So negative 3.39 this time. Okay. The lines from this surface here are going to be positive. So it's going to be plus 2.83. Okay. It's going to be minus because we're going to be heading toward that middle, that right hand center plate. So minus 1.13. And we're going to be headed to the left from this far right plate, so minus 2.26. All those put together will be minus 3.95 times 10 to the 5th newtons per coulomb. Good. Our last point is point C. That's right in the middle of that box. And in the middle, again, if we're looking at this far left edge, the lines are heading toward that edge, which if you're at point C are to the left, so it's going to be negative 3.39. Okay. The lines from the right edge of the left-hand slab, that left middle piece, those lines are going to point to the right, so we're going to add those again, just like we did for B. Okay. This time, though, lines that come from that middle right section, the left-hand part of the right-hand slab, those are going to be positive, so we're going to add that 1.13. But we're still going to subtract the 2.26 because lines that go away from it are going to go to the left as they go toward point C. So subtract those, we get 1.69 times 10 to the 5th newtons per coulomb. So you can see the sign really only told us what direction it was we needed to go. Okay. We had to use it independently each time.